Okay, so just like last time, what comes next? Let's do 2, 6, 18, 54. Question 1, question 2. Let's do negative 12, 6, negative 3, and then 3 over 2. And I'll go ahead and put question 3 over here, where I like 6, 4, 8 over 3, and 16 over 9. So I'll give you a chance to write those down. It's, what's next, right? What's happening? And you sort of go through this one and you think, what's happening here? And so what's happening? What's happening as we go to the next term?
Multiply by 3.
Is there, I see we're multiplying by 3? Right? Times 3, times 3, times 3. So in our head, we're multiplying everything times 3. So if I want the next term, I just take this and multiply it times 3. And that's going to give me 162. Right? All right, let's look at the next one. What's next? What's happening? What's happening from here to here?
Negative 1/2.
Okay, so you're multiplying by negative 1/2, right? You can almost think you're dividing by 2. All right? And don't worry if you're struggling with this, because this one's kind of tricky, right? So, so we're going to divide everything by negative 2. So we're going to say we're going to multiply by negative 1/2. And so if I multiply by negative 1/2, then that's going to give me a negative 3 over 4. So when you're multiplying, anytime you see the signs alternate, like it's negative, positive, negative, positive, negative, positive, that's a big clue that you're multiplying by a negative number. And, so 3 is a little tricky, isn't it? Oh, maybe not so much. Okay. Now, just curious, did you get the 2/3 from looking at the first 2 terms or looking somewhere else? Looking at the last 2, right? Sometimes when you're looking for a pattern, you don't always have to look at the first 2, right? You can look at any terms you want. And if you look at these last 2, you think, well, what happened to get from here to here where you multiply the bottom by 3 and the top by 2? And so we think, okay, we're going to multiply by 2/3. And so when I multiply by 2/3, that's going to give me, what's that, 32 over 27. So, does that part make sense? Now, the common theme in all of these problems is to get to the next term, you multiply, and that's what a geometric sequence is. Like an arithmetic sequence, you're adding or subtracting. Geometric sequence, you're multiplying, right? And with an arithmetic sequence, we have this thing called a common difference. With a geometric sequence, we have something called a common ratio. And so now I'm going to introduce some terminology for a geometric sequence. And the way I'm going to do it is I'm going to start with this first one. Okay? So we're going to look at this first example. In our first example, right? And anytime I deal with a sequence, I go ahead and put dashes because that's how I kind of draw pictures with sequences. So I do dashes. And this is the first position, the second position, the third, the fourth, and the fifth, and so on. All right? And in an arithmetic sequence, you have something called a common difference, where you take 2 consecutive terms and you subtract them. For a geometric sequence, we have something called a common ratio. And what a common ratio is, ratio means fraction, you take any 2 terms, any 2 consecutive terms, and you make a fraction out of it. If I look at these first 2 terms, if I do this over this, I get 6 over 2. That gives me a 3. If I take these two terms, 18 over 6, oh, that gives me a 3. If I take these two terms, does everybody see it? Right? When you have a geometric sequence, to find your common ratio, you pick any two terms, put the right over the left, and that gives you your common ratio. And just like an arithmetic sequence where the common difference was the most important part, the same thing with the geometric sequence. The most important part is what's my common ratio. So this over this, and like we use D for common difference, we're going to use R for common ratio. So for this problem, our common ratio is 3. Everybody see that? Now before I move on, because there's a lot more detail that I want to get into this one, while we've got that idea of a common ratio, let's look at question 3. That common ratio, notice that your common ratio is what you're multiplying by. Let's say we apply that here. What would we do? What would we get for our common ratio if we did a common ratio of the first two terms? See, if I take the first two terms and do this over this, I get 4 over 6, which is going to give me 2 over 3. I still get that 2 over 3, what we multiply by, right? And so you don't have to hope that you find two terms where you can find out what you're doing. When you have a geometric sequence, you can pick any two terms and do right over left. And that's going to give you that sort of that magic number that you multiply by. And that's a big, big deal, particularly when things get ugly. Right? Now, and what I did yesterday, I don't know if you remember, but yesterday when we talked about arithmetic sequences, everything hinged on the explicit formula. Like all the problems that we did when they got tricky was, first find the explicit formula, then you can answer the question. So what we need to do is, how do you find an explicit formula? Right? And there's a pattern, and I want to make sure we see the pattern. And I hate that I don't have, I just need more board space. So what I'm going to do is I'm going to rewrite this sequence. Right? You don't need to write. In fact, even if you're great at taking notes, I think I honestly just want you to look, right? Because I want you to see this pattern. And the way the pattern works is, so we know our common ratio is 3, and then I will have, this is position 1, position 2, 3, 4, 5. And I'll say position 1 is 2. Are we okay with that? Now, what did you do to get from here? What did you do to this first position to get to the second position? You multiply by 3. So you think, okay, we know our common ratio is 3, so we're going to multiply by 3. But I'm not going to say 6, because it's hard to see the pattern if you write a 6. I'm going to say this is 2 times 3. Is everybody okay with that? Now, what happened to get from here to here? Say it again. You multiply by 3 again, right? Is everybody okay? I mean, that's what happens. That's what a geometric sequence is. You're multiplying to get to the next one. So when I multiply by 3 again, let's see, that's going to give us 2 times 3 times a 3. Well, can I go ahead and write that as 2 times 3 squared? Right? Now, what's going to happen as I go from here to here? Multiply by 3 again. Any guesses as to what goes here?
2 times 3 cubed.
2 times 3 cubed. 2 times 3 cubed. Any guesses as to what goes here?
2 times 3 to the 4th.
2 times 3 to the 4th. Did everybody see how we got that? Now here's the key, right? This is huge. We're not going to write any of these. What's going to go here? 2 times 3 to the 9th. Can y'all see that? Let's look at the pattern, right? Right? Looking at this pattern is huge. Notice that every single term, even this one, and I'll talk about why this one still has the same pattern. Notice it has a 2 and a 3 raised to a power, right? Does everybody see that? Every last one of these is 2 times 3 to a power. And what's the relationship between the power and the position? It's 1 less. Does everybody see it? Right? Y'all see this pattern? Because if you can see this pattern and this pattern makes sense, that's your first big step into really understanding a geometric sequence. Right? Now, is everybody okay with this part? So now we're ready to write our formula. We're ready to write our explicit formula. Actually, let's talk about, since everything has a 2 and a 3 raised to a power, what's the significance of the 2? In our original statement, what's the significance of the 2?
It's the first one.
Are we okay? That's the first term? Is that obvious? What's the significance of the 3?
It's the ratio.
It's your common ratio. Does everybody see that? So notice that every single one of these values has the first term, the common ratio raised to a power. So if I want to write the explicit formula for this, I'm going to say a sub n equals my first term, which is 2, my common ratio, which is 3, right? And then the trick is what goes up here. N minus, can everybody see why it's got to be n minus 1? If the position is 10, we've got to make sure that the exponent's 1 less than the position. So if the position is n, I've got to make sure that the exponent is 1 less than the position. Does everybody see that? Does this formula make sense? Now, you may have looked at it, some of you may have looked at a book, or someone else may have shown you, but I want you to understand why this formula makes sense, not that you've memorized it. Right? But in a geometric sequence, what's important is, so if I want to find the explicit formula, there's 2 things that you need to know. You need to know the first term, and you need to know the common ratio. Because once you know the first term, you stick that here. Once you know the common ratio, you stick that here. And then you just put n minus 1 at the top. So now, let's look at question 2, which we already had. In question 2, I had negative 12, 6, negative 3, and 3 over 2. And the goal is I want an explicit formula for this. And for our explicit formula, we need 2 things. I need to know the first term, and I need to know the common ratio. What's the first term? Yeah, that was tough, wasn't it? What's your common ratio? All right, now remember, how do we find the common ratio? Is we look at 2 consecutive terms. You can pick any 2. Doesn't matter. You can pick these 2, right? So that's going to give me 6 over negative 12, which gives me a negative 1/2. Or I can take these 2, right? Or I can take negative 3 over 6, which also gives me negative 1/2, right? Everybody see we've got our common ratio? So it's pretty easy to find the common ratio. It's pretty easy to come up with the first term. So my explicit formula is going to be, well, our first term's a negative 12. And our common ratio is a negative 1/2. And I'll just make sure I put the n minus 1 at the top. Does everybody see how this formula generates this sequence? So now that I've set you up, right? Let's look at the ugly problem. And that ugly problem was 6, 4, 8 over 3, and 16 over 9. I want everyone to write down the explicit formula for this. Has everybody got it? Was it easy? All right, more importantly, was it easier than you thought it would be at the beginning of the period? Right? So you think about it, right? So the first important part is, what's your common ratio? So we already figured that out, didn't we? Right? Like it's what you did to get to the next term, and so I take 4 over 6, so that's going to give me 2/3, so my common ratio is 2/3. Is it pretty easy to find the first term? It's obvious. And so now I know that a sub n is equal to 6 times 2/3 to the n minus 1. All right. How does everybody feel about given a list of numbers, creating the explicit formula, right? You only need two things, first term and common ratio, right? And it's a big deal. How do you find the common ratio? Well, easy, right? Just take two consecutive terms and do that. All right, next. Oh, well, so the problem is we have explicit formulas and then we have recursive formulas. And I've got to make sure you know how to do each of those, right? And so for the recursive, what the heck is a recursive formula? Let's look back at that first example, 2, 6, 18, and 54. Oh, okay, let's put 162. And I want the recursive formula. Now, here's how recursive formulas work. Recursive formulas work by you have to tell me what the first term is, and then you have to give me this little formula where it's a sub n equals, something with an a sub n minus 1. Every recursive formula starts off like you have to tell me this and you have to tell me this. So let's fill in what we know. Do we know what the first term is? We got to have a starting point. So my starting point, a sub 1 is 2, right? Now, here's the neat part about the recursive formula as it relates to a geometric sequence. What are you doing to get from one term to the next? We've already answered that, right? We're multiplying to get to the next term. And so we've already established our common ratio is 3, which means the way you define your recursive formula is a sub n is equal to 3 times the previous term. And what this is telling us, it says start off with 2, and the way you get to the next term is this is telling us start with 2, and the way we get to the next term is multiply it times 3, which gives us a 6. How do you get to the next term? Multiply this times 3, which gives us 18. So when you have a recursive formula, when you have to create a recursive formula, you make sure you have to tell what your initial term is, and then how do you get to the next term? Is everybody okay so far? And the difference between that, it's very similar to the arithmetic sequence. Arithmetic recursive one is a sub n minus 1 plus something or minus, like you're adding or subtracting in the next one. All right, so is everybody okay with the entry level stuff? Like that's the first part of today's lesson is, okay, what is a geometric sequence? How do you define it, either explicitly or recursively? The recursive is, for the most part, is useless, but I'm going to ask questions about it. The big idea was, how do you come up with an explicit formula? And, I guess I should have done this earlier. So for this problem, we had our explicit formula was a sub n is equal to 2 times 3 to the n minus 1. Right? You remember that was our explicit formula? If you look in your textbook, or any textbook or anywhere online, when they say, what's the explicit formula for a geometric sequence, they're going to tell you the explicit formula is a sub n is equal to a sub 1 times r to the n minus 1. Can you see why they would say that? Right? Is that very obvious where they came from now? And some of you may have already seen this formula, and that's great. I just want to make sure you understood where it came from. That's your first term, that's your common ratio, the n minus 1. All right, so slightly trickier problems. Yeah, I got to do this. I want to do one type of tricky problem, and then I want you started on your Khan Academy assignments. Because I want to make sure the basic stuff is solid before I start doing the tricky stuff. So, if I want an explicit formula, and let's say I don't give you exactly what you want. I tell you the third term is 28, and the common ratio is 2. And your goal is what's the explicit formula? right? So if your goal is the explicit formula, what two pieces of information do you need so that you can find the explicit formula? The first term and the common ratio. Everybody okay? Well, I already gave you the common ratio, right? So if I already gave you the common ratio, we can go ahead and say, well, a sub n is equal to, well, I don't know the first term, but I know my common ratio is 2 to the n minus 1. Is everybody okay with this? And your job is, you got to figure out this. So I'm going to give you the non-mathematical way. This is, if you don't remember formulas, right? And to be honest, I would probably do it this way, right? I just want to make sure that you're sure where it's an option. Draw a picture. See, when I say draw a picture, this is a sequence. This is a list of dots, you know, like first, second, third, fourth, fifth position, right? What do we know? What's the one position we know? We know the third position, don't we? Did everybody see that? We know the third position, and we know that third position is a 28. What else do we know? We know the pattern. What happens as we go this way? Multiply by 2. So what happens if you go this way? You divide by 2. So what's this position? 14. What's this position? 7. Does that make sense? Did I find my first position? So I've got my common ratio. I found my first position, so I know that a sub n equals 7 times 2 to the n minus 1. That wasn't too bad, was it? Now, that's fine until, what if I told you that the 30th position was 28? That's a whole lot of figuring out backwards, isn't it? So how do you do it if it's not close, right? And the way you do it if it's not close is you actually have to write an equation. And here's how the equation looks. So I want to go back to this thing. Say a sub n is equal to 2 a sub 1 times 2 to the n minus 1. And this is kind of what some of the stuff that we did yesterday. A sub n is the value, which is this. N is the position, which is this. And so what I know is the value is 28, so 28 is equal to a sub 1, 2, and then 3 minus 1. And so that gives us 28 is equal to a sub 1, 3 minus 1 is 2, times 4. And now I can solve, I can divide both sides by 4, and so I end up with 7 is equal to a sub 1. If you look up in a textbook, this is what they're going to tell you to do. Right? Because that's the job of a textbook. In practice, personally, if I were taking the SAT and they gave me this, I'd be drawing dashes. The reason I would be drawing dashes is I understand how the dashes work. And a year from now, I may not remember that formula. But I can always remember dashes and how to think about stuff. And what I really want to do is give you the tools so that a year or 2 years from now, or whenever you're taking the ACT or the SAT or the ACT, you don't have to say, what was that silly formula? I want you to know this is how you think about it. That's going to be more valuable. All right, so here's what I want you to do.